Okay, here we are. I wasn't quite ready yet for all that, but 4-3, day 3. Day 2. All right, I'm set. 4, 3, day 2. Okay, remember you should be filling in your blue sheet. So at this point, you should have all 4 of the derivative rules filled in up here. Power, chain, product, and quotient. So make sure that's filled in so you have it for the quiz and the test and the rest of it. Today, not a whole lot new. We are looking at just a couple of examples. We just really want to get good at these derivative rules because it's your lifeline in calculus. So if I give you an equation where a equals sine to the fourth x over x to the sixth, I want you to be able to do this with your quotient rule and with your product rule and show that the two answers do come out the same. So we're doing derivative two ways. Quotient rule and product rule. Okay, if I didn't tell you to do it two ways, you probably would have just went with the quotient rule. So you would have seen an x term divided by another x term. So we'll jump right into quotient rule. So a prime, we need the derivative of the top. I am going to take the time to rewrite this as parentheses to the fourth power. Now I can see it's a chain rule where I got the inside and the outside. So 4 comes down, times sine x to the 1 left power, times the inside derivative of the cosine x, and then I still have to multiply by the bottom. So that's my u prime times v minus, keep the top the same, sine x to the fourth, and now the derivative of the bottom is 6x to the fifth. And then that's all over the bottom squared. And that's going to make, remember, the power of the exponent rule here is multiply. So that's going to make x to the 12th. All right, we need to simplify this. So we're going to factor the top. The top has two baskets, this one and this one. So we've got a 6 and a 4. We can take out a 2. I've got x to the 6th and x to the 5th, so I can take out an x to the 5th. I've got 3 of the sine x's and 4, so I can take out 3 of them. And now I'd like to do the square bracket and then say what's left. So I had a 4, divide out a 2, that leaves a 2. Add x to the 6th, took out 5, that leaves an x. Add 3 of those, took out all 3. So that leaves the cosine x. Now the second basket, we had a 6, divided out a 2, that leaves a 3. Took out all the x's, so none of those. Took out 3 of these, so I have a sine x left. And then that's all over x to the 12th. As far as inside here, nothing. These two terms here are not like terms. That's as much as we can do there. The only simplifying I can do is cancel my x's. Got 5 x's here. I'm going to cancel off 5 of them here, leaving me with 7. Okay, so at this point we're going to stop. We've done all the simplifying. We just have to make this answer look like the product rule one, or we make the product rule one look like this one. So I'm going to leave some room in case that's the one I want to change. So in order to do product rule, I have to have a product of 2 x's. And the only way I'm going to get a product of 2 x's is to rewrite this and bring this x to the 6th up so that it's multiplied by the numerator. So I'm just going to rewrite this. I'm going to keep sine x to the 4th. And then when this comes up, it just has a negative x going on. And now I can see I've got a u times a v. And now I can do the product rule. So A prime now is the derivative of the u is a chain rule. There's my inside and outside. 4 times sine x to the third. And the inside derivative is cosine x. Derivative of x is 1. I have to mention that up there. So there's my u prime. So I have to multiply by the v. Plus, keep the u. Times the derivative of the v is a negative 6 x to the negative 7. Okay, so I'm going to factor this one because I need to get this stuff to, well, maybe not. Let's see, we've got 4 x to the negative 6 sine cubed x cosine x. Here, I'm going to bring this to the front of minus 6x to the negative 7 times the fourth x. Okay, can I make, let's see, which one do I want to change here? I'm going to change this one, I think. I'm going to make this one a fraction, because I've got a negative exponent here that I can factor out. I'm going to factor out the two baskets again. I got a 4 and a 6. I'm going to take out the 2. I've got x to the negative 6 and x to the negative 7. The smallest one is x to the negative 7. Think about a number line, and the farther you are to the left, the smaller you are. So we're going to take out x to the negative 7. And then I can take out a sine cubed. X. So that would leave inside here at a 4 divided out of 2. X to the negative 6. When I divide this out, I'll show you real quick. If you have x to the negative 6, and when I take this out, I'm dividing it out. The rule here is when you divide, you subtract exponents. So negative 6 subtract a negative 7. It's going to leave you with an x. Or just think about, when I distribute this back in here, x to the negative 7 plus what power is going to give me a negative 6 back, and that's going to be a positive 1. Okay, the sine cubed is out, and I still have the cosine x. Minus, I had a 6, divided out 2, that leaves a 3. Took out all of the next x to the negative 7, and I took out 3 of those, that leaves 1 of these. Okay, the only thing that's different now, I've got the 2, I've got the sine cubed, I've got the 2x cosine minus 3 sine. The only thing is I've got an x to the 7th in the bottom of this. Well, because this is x to the negative 7th, if I shove it back down to the bottom here, it now has its happy exponent on, x to the 7th. And now the two derivatives are identical. So there it is. If you like to rewrite and use product rule, you can. Number 2, we've got a of x equals 20 over sine squared x. Again, 2 ways. We want a derivative, a quotient rule, and a product rule again. 2 ways. Quotient and product. Okay, you may not have thought of this as a quotient because there's no x term up there, but you can still use it as a quotient rule if you think of it as x to the 0 power. So x to the 0 is equal to 1. So you're going to have to write that in there. You could still do quotient rule even though it's not an x up there. So quotient rule first. Our derivative will be the derivative of the top, which is 0, times the bottom, which I didn't even really need to do. It's going to cancel out. Minus, keep the top, multiply by the derivative of the bottom. I really like to see the parentheses. then I know it's my chain rule, outside, inside. 2 comes down, times sine x to the first, which I don't even need parentheses for. The derivative inside is cosine. And then we're all over the bottom, which is sine squared, and I need that squared. So I'm going to factor the top, or I don't even have to factor, that goes away, that's 0. So we're going to have negative 40 sine x cosine x all over sine, we multiply here, I guess you would have got right if you added, sine x to the fourth, and then the simplifying that I can do is I can cancel off one of the signs. That sign takes away one of these. We got negative 40 cosine x over sine cubed x. Okay, see if we can get the same thing with without doing quotient rule. That means we have to rewrite it first. So let's take it out of a quotient. So if it starts 20 over sine x squared, got to get rid of the denominator to not do quotient. We're going to bring it up and make it a negative exponent. So 20 times sine x to the negative 2. At this point, you could do a product rule and think of that as your x term, or I just like to think of it as a multiplier that's going to carry along times this derivative. So I'm just going to carry the, let's start my chain rule. The negative 2 is going to come down and get multiplied by the 20 that's there and give me negative 40. Sine x to the 1 last power, that's going to give me negative 3, times the inside derivative is cosine. And all I have to do to make this one look like this one is make this exponent happy. So if it's unhappy up in the numerator, put it down in the bottom and make it happy. Negative 40 cosine x all over sine x and cubed x. Now they're identical. Okay, do I need that one? Boys, I might just make your day today and call that good. I don't think there's anything in this last one that's too tricky. Oh, yes, there is. That's why it's there. I lied. Last one. Okay. Only drawing the derivative one way this time. P of x equals 1 over cosine x times sine x. Okay, so we have to do a quotient rule because the x is down in the bottom. But if you look at the bottom's going to have its own product rule. So here we've got a product rule within a quotient rule. So we'll start with the quotient rule, u over v. The quotient rule says take the derivative of the top, which is 0, times by the bottom, which isn't even necessary, but I'll just go through the motion, minus, keep the top the same, multiply by the derivative of the bottom. Well, because the bottom is a product, and I've got to subtract out in front of it, I better not forget these brackets, because the negative 1 is going to have to get distributed in. That's the trick to this one. So now my product rule, I've got a u and a v. So I take the derivative of the u, which is negative